Hello, it is Dr. Lou. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using Kids from Science Interactive. In today's video, I'm going to go over the procedure for colligative properties lesson. I will break up the video into 3 parts to correspond to the 3 sections of the experimentation part of the lesson. In this video, we will look at osmosis and dialysis. This video is the first of 3 parts dealing with colligative properties. In the series of videos, we are going to be looking at osmosis, freezing point depression, and boiling point elevation. Let us focus on osmosis and also dialysis. So I want to give us some definitions. So, osmosis, movement of solvent across membrane to equalize solute concentration. The key for osmosis is we are talking about solvent, which is going to be moving. So the other term is dialysis. Dialysis is the movement of solute across membrane to equalize solute concentration. For dialysis, we are talking about the solute. So osmosis, movement of solvent. Dialysis is movement of solute. The goal is to try to equalize the solute concentration on both sides of the membrane. Let's look at a couple more terms. So, if we have a hypertonic solution, there is a greater solute concentration than reference solution. And when we have something that is hypertonic, water, which is the solvent, flows into it. And when water flows into something, we will have hemolysis. And hemolysis means to burst. Thinking about blood cells, if a red blood cell is hypertonic to the surroundings, then water will move in from the surroundings into the red blood cell and cause it to burst. The other type we can have is hypotonic hypotonic solution. So if we have a hypotonic solution, we have a lesser solute concentration than reference. So water, which will be the solvent, flows out, causing crenation, which means to what? Shrivel. So for example, if we take a red blood cell and the red blood cell as hypotonic to its surroundings, water will leave the red blood cell and go into the surroundings, causing the red blood cell to shrivel. Last one is isotonic. Isotonic means equal concentrations. And if we have equal concentrations, that means we stay nice. So in terms of dialysis and osmosis, especially osmosis, I should say, if we have isotonic solutions, there will be no net movement of solvent in these cases. So pay attention to these definitions because you will be asked to explain with these definitions what is happening in the experiment. I want to show you a brief schematic or picture I took. So in the experiment, you're going to have dialysis tubing tied up with rubber bands sitting in a beaker or a plastic cup full of water. Let me draw an arrow. So let's see if I can draw this arrow. So what's going to be in the dialysis tubing itself? So what's going to be in the tubing is fructose, otherwise known as corn syrup. Outside of the tubing is going to be distilled water. At various time intervals, you are going to carefully dry and weigh the tubing to look at the change in the weight of the tubing. So I can write if tubing weight increases, water flows in. And conversely, if the tubing weight were to decrease, water would be flowing out of the tubing. So if water flows in to the tubing, then we can say the solution inside what? Hypertonic. The other scenario we said is if tubing weight decreases, water flows out. If water flows out, that means we have a solution. Inside is hypotonic. So as a recap, in the experiment, we are looking at osmosis, and we want to look at the direction of water flow, whether it is inside or outside of the tubing.